The Conversational Flow, a KCAS podcast.
Hello, and welcome to the 12th episode of The Conversational Flow, an official podcast of KCAS Bioanalytical and Biomarker Services. KCAS is a bioanalytical CRO serving the pharmaceutical and biopharmaceutical industries for over 40 years. Unlike KCAS' other podcasts, the weekly Bioanalysis, which features news and topics more generally associated with the world of bioanalysis, the Conversational Flow focuses more on the niche of flow cytometry and its role within the greater industry. My name is Adam Cotty, and I've been in the flow cytometry space for over 15 years. I'm here with my co-host, Brian.
Thanks, Adam. My name is Brian Weil. I've been in the flow cytometry CRO space for over 12 years.
We're also joined by two special guests today, Ryan and Sean. Would you guys like to say hi?
Hi.
Hey, thanks for having us.
Excellent. Brian and I are members of the growing leadership and scientific advisory team at KCAS. Either or both of us are available to answer any questions you may have regarding this podcast or any of KCAS services. While our KCAS headquarters are located in Kansas, and I'm currently in the Kansas location, usually out of Philadelphia, but I'm traveling today. We've also got a location in Europe and a partner lab in Australia. Brian is in Philadelphia. Our producer is here in Missouri, and our guests are from New Jersey and British Columbia. So we are truly all over the map. We're ecstatic to have you listening to our 12th episode of our podcast, which will be available virtually everywhere. Wherever you choose to find and play your podcast, you'll likely find the Conversational Flow. We welcome all of you, whether you're joining us for the first time or if you're a regular listener to any of our other podcasts. Today's episode will be a review of the latest news and resources and then a focus on a topic of our choosing before discussing any feedback we've received from you. We're constantly looking for topics and we'd be happy to discuss something that you want us to cover. So again, we're fired up to have you here and we're looking forward to a fun episode today. To kick us off for episode 12, Brian is going to go over news and resources before diving into today's topic. Brian?
Thanks, Adam. We do have a full slate today. So to start off with medical research news, the first article is around cancer immunotherapy with bispecifics versus CAR-T.
Yeah, and I thought this was a really interesting article. One of the things that it highlights as far as therapies like this, when you're talking about bispecifics, is the number of T cells that are localized within the organ that you're talking about for cancer immunotherapy. And some of the organs have fewer T cells. So in this case, we're talking about a bispecific for prostate cancer, right? And what is a bispecific? It's an antibody that essentially has two different arms, bringing two different things together. One side is engaging T cells. The other side is engaging the cancer cell. And so when you engage the T cell, what you try to do is activate it and get it to then kill the cancer cells. One of the big things around this is checkpoint inhibitors, very well known for allowing the T cells to do their job. At times, what happens is with cancers, the T cells get deactivated, downregulated, what have you. And so when you have checkpoint inhibitors, you allow the T cells to then go do their job. And so by having these bispecifics, you bring these T cells in localization with the tumors and then allow for killing. There's very much an unmet need here, specifically for prostate cancer. It's something where the cancer cells will actually feed on testosterone. And what happens is eventually you can reduce the testosterone as a therapy, but they become resistant to that. And then that becomes castration resistant, right? And then when the patient gets to that point, generally they're about two to 3 years left in life, right? And so we want to get therapies that are effective in this area.
And the two things that I found most interesting about this paper are, just with bispecifics in general, I like to think of them as a almost like an antibody drug conjugate, where instead of a drug payload like some sort of chemotherapy agent, it is now a cell payload. So as if the antibody is bringing in a new cell type to target the cancer cell. So an interesting way to do it. And I also like the sort of juxtaposition here between the bispecifics versus the CAR T cells, where the bispecifics are really making the most out of what you've got versus the CAR T cells potentially training a CAR T to do something it's never learned before, and then bringing it back in.
Making it do new things, right? Something like that. No, I like the way that you think about it. I didn't frame it as antibody drug conjugate, but I can certainly see where you're going. Now, the one thing you and I were talking about when you brought this up, to me, seeing bispecifics as new, emerging was interesting because in my career, I had been working on bispecifics for well over a decade, right? Now, granted, I was in development at the time, so things were coming out newer. It takes 10 to 15 years for something to go from development to the market. And so for the general public, maybe bispecifics look newer than they do to me. But then juxtaposing them right against the CAR T, like you said, it's interesting to see too that some of these bispecifics do have very similar side effects. So one of the well-known side effects for CAR T is cytokine release syndrome. And, what happens there is an influx of cytokines, specifically IL-6, which is responsible for fever. And treatment is using something like a tocilizumab, which is an anti-IL-6, to then reduce the impact there. But just very interesting to see these two therapies, emerging and really driving therapies right now.
And that is that second thing that I found most interesting, that, to you and I, like, bispecifics is like, oh, this is old hat. Like, haven't we been doing this for like decades now? Mm-hmm. But, if you're a cancer center trying to recruit patients, they don't know what standard of care is necessarily. And, spoken to a couple oncology doctors and MDs and things like that. And, for those that are not regularly participating in clinical trials, they're nervous about trying out new therapies on their patients, right? They don't want to use their patients as a guinea pig, which, makes sense. Make sure to give people things that are evidence-based and test as much as possible. But it really just goes to show that, yes, we need to meet these FDA requirements, but we need to give doctors as much evidence and information as possible to make those decisions and feel comfortable with those decisions before they roll things out to the patients. Otherwise, it takes a very, very long time to roll these out and make these standard of care, bring these up from a third line treatment, like everything else has failed, let's throw everything against the wall and see what sticks, up to the second and first round treatment offered.
Mm-hmm. Which I think is very counter to the next article that you have as far as timelines. When we're looking at generating flu vaccines, not to totally scoop your article, you have to identify variants very early on. And so I'll lead in with that and let you open up your article there.
Yeah, no. So this next one is around CSL, Sanofi, and GSK starting out their flu vaccine as soon as possible. So they actually shipped in mid-July for this upcoming flu season.
Right. And one of the things that's coming out right now is a change in the way that the flu vaccine is being pitched. The whole slogan of wild to mild. I think a lot of people, when they hear vaccine, think that automatically what that means is I'm not going to get it. And with the flu vaccine, that's not generally the case. That doesn't mean that it isn't effective. Essentially, if you get the flu vaccine and it reduces the symptoms, that's a win, right? Because children, elderly, are very much at risk for the, succumbing to the flu. And so if they get the vaccine, the likelihood that they have major complications is lowered.
Yeah, and very similar to bispecifics, you're training your body to do better whenever it encounters that disease in the wild, right? And so every year that you get the vaccine, maybe it's only 15% effective one year, but maybe it's 40% effective next year. But each time you're getting that vaccine, you're gaining sort of a new skill. Your cells are able to respond in a different way than they were before, or at a different velocity than they were before. So you're building up that different level of immunity. And, after 30, 40 years of that, all of a sudden you're you've got a pretty broad spectrum immunity to a lot of different flu strains.
Right. And I think it's really important when we're talking about vaccines to bring up what herd immunity is, right? Um, I think we've seen a lot in the news recently about there being pushbacks on vaccines, and the numbers of people that are getting vaccines are being reduced. So why is it important to get a vaccine? It's twofold, right? There's the importance for yourself to reduce your own risk, but then there are other populations of people that cannot get the vaccine for whatever reason. Maybe they have weakened immune systems going through chemo. As I mentioned, young and elderly, maybe more susceptible. Elderly specifically, the T cells just don't respond to a vaccine the way that younger people do. And so what you need is to get to a point of herd immunity. Now, what does that mean? Well, when you have enough of a population vaccinated, you don't have to have 100% to protect those that are at risk. Different diseases have a certain percentage that they need to reach to be able to be effective in herd immunity. So, for example, measles requires 95% of the population to be immune, whereas polio is lower at about 80%. However, with the rates of vaccination for these diseases, measles now is at about 90.8% for those aged 24 months. This was data from 2020, 2021. And so, with that continued pushback on vaccines, you're starting to see measles get below that threshold for herd immunity. Now, polio is remaining at 92.5% as of the last information I could find. And so still herd immunity there. But what you risk is all of a sudden starting to see these diseases that have been squashed starting to come back.
Exactly. And, just to bring it back to a drug development perspective as well, you mentioned that the way that flu vaccines are developed and how quickly they need to be developed, because of course that strain is changing every year. So we have to be in a constant race to be predicting which strain is going to show up, which hemisphere, and when. So the way that a lot of these drug makers will operate is that they'll have basically one development season in one hemisphere and then bring the most likely drug into the other hemisphere later on. And then likewise test out the next drug for the southern hemisphere, in this case, in the northern hemisphere when it's flu season in the northern hemisphere, and then bring it back to the southern hemisphere for that second season. So it's just a really, really rapid pace of things going on with lots of different subjects, because you have to have a statistically powered data set there. And just a lot of interactions, especially with the flow cytometry arm, as we mentioned, with antibodies being generated and herd immunity and, basically antibody memories in different cell subsets that then is really fun to tease out and think about. And that's one of the things that we'll get into with our high dimensional flow a little bit later on.
And, you just gave a great segue for the investments for the next section. You're talking about data, and next section is going artificial intelligence and therapeutic design. So why don't you kick that one off for us?
Yeah. So there, I picked a story on Recursion Pharmaceuticals. So there's basically a new crop of companies that are saying that they will use AI to generate drugs more efficiently. And that could be either more efficient discovery, more efficient trial design, more efficient biomarkers, or some combination of all of them. So this is definitely a highly watched company that is promising AI drugs. This first drug isn't really an AI drug, if you will. It's a repurposed drug where they knew a drug was effective in a different indication, and now they're repurposing for a new indication. I think of it as a training run for the company to make sure that they know how to bring a drug all the way through clinical trials before they start operating with their actual AI developed drugs.
Now, before diving into the science of the company, the AI and everything, the one thing that struck me, and it's in the relationship to the investments portion of this, as you read through, you hear feedback from people talking about how, if this fails, the company's going to drop significantly, and like the whole market for this is going to be in tatters. And it always strikes me because I am interested in stock market and stock trading. I'm not a day trader or anything like that, but I just like to watch it. And it strikes me how much more there is an emotional component to the stock market than there is an actual component based on data. I'm sure that hardcore stock people might argue with me, but you see Nvidia come out with fantastic numbers, for example, and then the next day their stock just tanks, and so it cracks me up that you could basically pin all the hopes of AI in therapy on one company and give that sort of feedback. I don't see it that way. I think AI is going to play a huge role as we move forward in therapeutics. Now, we've talked about before that long has the therapy been one disease, one gene, and so you're going to start to see us answering more and more questions, AI answering more and more questions, or helping us in that realm, finding the interconnectedness of not only the genes, but then, nature, nurture, all that kind of thing, your environment, how does that impact? Because I have from personal experience seen with genetic analysis, somebody passes and one of the genes is implicated. However, it's something that there's just not enough information on right now. And it seems like it would be a plausible reason, with why the person passed. And it's hard to just wait for that data to come in to try to further understand what had happened. And so with AI, I see definitely in the next several years, 5 years, 10 years, what have you, where all these giant data sets, all this information is being brought together and lights are going to be shined on areas that just hadn't been. And, specifically, I think this is a lot of what recursion is looking to do.
Exactly. And, I think both this story and the next story then are somewhat tied, because I always think about that silly video about the basketball players and the gorilla. Are you familiar with what I'm talking about?
I am. I don't think I am. Please explain.
So there are, I think, 3 people playing basketball, right? They're bouncing a basketball, passing it around, and you're given a task and you say, like, watch how many times the basketball is passed from person A to person B and count them. Mm-hmm. So the first time you go through, and by the end of the video, you get through and you're like, okay, I think they passed it 7 times. And the announcer's like, great, you got exactly right. Did you see the gorilla? And you're like, what are you talking about? And when you go back and watch the video without trying to count the number of passes, mm-hmm. all of a sudden you see a gorilla walk through the screen that you just had no idea, because you were counting the basketball passes, and you don't realize that there are other things going on that you're not looking for.
Right, and that's the whole witness thing. People think they saw everything, but it's obvious you don't see everything.
That's it, right? And so when we're developing these drugs and we're looking at a very specific indication, we're not thinking about how they could be related to every other indication that's out there, because that's not humanly possible. But it is AI possible, and that's what the tie-in with the next story is too. That biotech M&A has been extremely focused on immunology, actually, in the past year. So, I linked to an article from Biopharma Dive that just looked at the M&A deals by therapeutic category, and this is the first year, 2024, is where immunology has outpaced cancer or all other indications.
All right, and so looking at autoimmune diseases, right, and trying to see what can be done there. And it's interesting because some of the companies have been repurposing the CAR Ts for autoimmune therapies, going along that line. And it makes sense. A lot of these autoimmune diseases are B cell based, and so if you have a therapy that targets B cells, you could potentially reset these sorts of conditions. It's very much what I was looking into when I was doing my thesis work. My own was more in the macrophage space. Always had an affinity for big eaters. Anybody who knows macrophage knows that term means big eater. So, my buddy's there. But you're right. And so article that you sent had a cutoff, I think it was, of about 50 million. So there were a few that weren't mentioned in there. However, in 2024, there are several companies under that line that also continued this whole march towards autoimmunity, such as Century acquiring Clade, LEM Therapeutics acquiring Tenet, and then Charisma and Moderna expanding a collaboration on in vivo CAR-M therapy. And so you're right, it certainly is moving in that direction, and it's good to see because it's something that is, again, we talk about unmet need, and there's a lot of unmet need in medicine.
There is. And, we've been so focused on counting exactly how many cancer cells that we kill that we have not noticed that the gorilla of autoimmune diseases are walking around, and we could probably use the same drugs to also tackle them, right? So, yeah, that's absolutely a good thing, and absolutely something that I think AI companies can excel at and deliver a lot of value on. If we have a drug that we know is safe in one indication, then that de-risk significant parts of the pathway, and all of a sudden our clinical trial success rate goes from the paltry, I believe it's still somewhere around 5% total, to a much higher number, and you get a much higher number of drugs available and treatments that you can actually have a shot at taking down in some meaningful way.
And now moving to our next segment, what are we doing to help in this arena?
Of course. So we have finalized the installation and harmonization of our Cytec Auroras at all three of our sites. So Natalie Carroll did travel to both Lyon and Melbourne. So she just completed her work in our Lyon facility, and basically the instruments are performing beautifully. The results that they're obtaining are very, very similar between sites. And we've now harmonized an assay so that we can run it off the shelf for any trial. So we can start it up in as little as 2 weeks if we need to.
Yeah, it was quite the whirlwind for Natalie. She went out there as one of our subject matter experts on Cytec and did a fantastic job. Really, it was incredibly smooth. I'm sure that from her perspective, it didn't look so. Anytime you're in the weeds and in the details, you're trying to solve things in real time. But she and the team did a fantastic job to make sure that the experiments were done. They were done correctly. Analysis came through, and really great job by the team there.
Absolutely. So looking forward to more things, and then it'll help us with flu vaccine development, right? So if they need a lab in the southern hemisphere, we've got it. If they need a lab in the northern hemisphere, we've got it. So great.
I was thinking, I love it. I see. This is why you're the head of the site, man. You've got all the angles.
Indeed. But now that we've got spectral everywhere, it opens up some more possibilities, and also, of course, some more risks that we need to be aware of. So I think this is probably a good time to introduce our guests and let them talk a little bit more about their background, and then go into our paper on 50-color phenotyping. So Sean, if you wanted to give a little bit more of a detailed intro.
Yeah, hi guys. I'm Sean Burke from Denovo Software. Thanks for having me on today. I really appreciate it. I've been working with the team at Denovo Software for it's got to be the last 14 years now. I'm currently president at Denovo Software. My background prior to Denovo Software, I worked with image cytometry, kind of cut my teeth with flow cytometry at New York University, and been kind of building a career around flow cytometry from there, and been able to see some really, really cool things happen, in the last 10 plus years, as spectral cytometry has become, more and more prevalent. I remember going into labs many years ago, and, they were just onboarding spectral cytometers, getting multiples of them coming in rather than one at a time. So hopefully I can, give some nice insights on what we've seen in the high dimensional world for flow cytometry data analysis, and kind of some of our approaches and thoughts around working with high content data, and also kind of what high content data means as well. I know that's a kind of a vague kind of description. So I think that's a little bit about me, and again, looking forward to having a few more conversations around this today.
Excellent. Thanks, Sean. Ryan, do you want to give a brief intro?
Yeah, and thanks for having me here today. So I'm a vice president of R&D for Flow Cytometry at Dotmatics, Inc. That's the parent company of FCS Express, OMIC, EasyPanel, and a whole bunch of other scientific software companies. Before that, previous to my career as a prophet, I was a professor at University of British Columbia in medical genetics, and my whole career has been based around bioinformatics on flow cytometry data analysis. Along the way, I started up a company called Cytopex that offered automated data analysis solutions to big pharma, and that got picked up by Dotmatics, and that's how I ended up there about a year and a half ago.
Nice. Excellent. So definitely the perfect crew to talk about high content data. I did put in just one of the recent omics that came out. So this is a 50 color phenotyping panel out of Florian's lab in Switzerland.
And I just have to cut you off. You said OMIC. It's an OMIP. We have to be very
careful. Yes, OMIP, correct.
Especially, as Ryan mentioned, has OMIC underneath him there.
Indeed. Maybe just a background on OMIPs too, and OMIP. And I actually forget exactly what it stands for, but it's essentially a standardized flow cytometry assay that has enough data published that another lab should be able to reproduce it. So it was established as a major sort of push by the International Society for the Advancement of Cytometry to standardize flow cytometry as much as possible and make results more robust and reliable between different labs.
Right, and it's published in Cytometry Part A, which has an impact factor of 2.5 as of 2024. And we do that regularly for all papers, so just wanted to make sure we had that. I think we've already mentioned Cytometry Part A before.
Sure. And Adam, do you recall what OMIP stands for, OMIP?
I had a feeling you were going to ask me that, and I did not. As our producer mentioned, I closed down everything and I spaced on it. It's one of those being caught in the moment sort of things. So, hold on. It's optimized multicolor immunofluorescence panels. I did have it in my notes. There we go.
Excellent. All right. Appreciate that. So definitely a great way to share really detailed panel information. And in this case, really highlight the capabilities of spectral cytometers. So in this case, of course, Florian was trying out the new BD spectral cytometer, but the 50 color phenotyping itself is definitely a capability in theory of different cytometers.
This one, I really like to see the way that they went about it. To me, when you get to OMIPs, I think they're very helpful for when you want to solve a specific problem. You've got a panel of specific markers, and I think all of that information is fantastic. And obviously, with what we do, I recognize the amount of work that goes into building a panel. I think the most interesting thing for me, though, is what goes on behind the scenes as far as how many steps there are in building a panel, and then on the back end too, data analysis, right? And so some of the resources that they mention here are the BD handbook of CD markers, which is fantastic in being able to identify different markers for different cell types. Use of things like EasyPanel, which is a program that helps build your panels, looking at the markers, the fluorochromes, all sorts of things like that. The machine that you're working on, basically considering similarity index and then what would work together and what wouldn't. Now, the reason I bring that up is because historically it's been a very manual process. My thesis work, I was basically taking all the markers, I put it into a spreadsheet, then I'd have to go and I'd have to look at everything that's available, the number of fluorochromes for each marker, for example, and slowly build it out that way. And part of it is you're hamstrung by how each marker, how many different fluorochromes are available, right? Some of them are just PE or APC, whereas other ones may have many different colors associated. And you just whittle it down that way. And it's time consuming. Now, with some of the things they mentioned in the paper, it's much more robust.
It is, absolutely. And, you can think about with the old panels, let's say you've got 8 colors, right? There's only so many ways that you can combine those 8 colors. And, we're helped by biology. There are only so many reasonable ways to combine those 8 colors. When you start to think about 50, then you've got problems. And that brings up the first question, right? So why is this amount of data challenging to deal with? So maybe just to start out there, Sean, where do you draw the line, I guess, between high content or high dimensional panel and a low dimensional panel?
Yeah, it's just to go to your point too about the paper. The one interesting thing I noticed was that there was 3 pages in the supplemental about
Yes.
here are reasons why things don't work, right? So I think it goes to the point of like how challenging and how much time actually has to go into that, and I can talk a little bit about that later as well. But yeah, I mean, it's I think it varies for everybody. What is high content? What is high dimensional? For some folks who are using a 5-color flow cytometer, 8 colors, 10 colors seems unreachable. It seems unfathomable. But I'd probably put somewhere around like 15 markers if I had to pick a number out of my hat. We're kind of moving into high dimensional. It's getting really hard, if not impossible, to kind of visualize what's going on with 15 markers and a kind of classic bidimensional type plots. But high content is also an interesting thought as well, because I mean, does high content mean you're just running 100 tubes? Does it mean you're running 100 384 well plates? From that kind of perspective, I think there's a lot of people that are doing what would classically be considered high content, where they're running 96 well plates, they're running tens if not hundreds of those plates a day, and then it gets even more interesting and more complex when people now have the capability of running a 96 well plate with 15 plus markers day over day over day. So I think all these things kind of compound, but again, if I had to put a number to what's high dimensional, I'd probably be looking 15 plus markers.
Exactly.
So that's interesting though, Brian, because that means that we've been doing high dimensional on our Fortessas for a while. We've been going up to 18 there. So yeah, I just had to put that in there. I always think about high dimensional as like the crossover from the Fortessas to the Cytex, or from standard to spectral there.
Agreed. Yeah. So it is interesting where exactly people draw the line, right? So our next episode is actually going to be on low dimensional and what you're actually able to do and how important that is. But I agree, like for different groups, it could be 12 colors, it could be 15 colors, it could be 18. Somewhere around the 15 to 20 realm, I think is a pretty good consensus statement. And Ryan, any thoughts on? Oh, sorry, go for it.
I did want to say just one other thing. When I first started out in flow cytometry, and I'm doing 2 to 3 colors, anything beyond that was high dimensional. So.
There's this great paper by Bob Murphy. It was written a long time ago. He's like, "Oh, we're now doing 5-color experiments. This is really hard." It's like an exact quote in the paper. We need to automate this.
Yep.
And that was true.
Yeah, that's it. And here we are. And then that leads to that question, right? So how do we make this manageable? So it becomes challenging, just from a data storage and a file management things, right? So basically each of these files comes off in at least one FCS file. In some cases, and in most cases, if you're doing things right, you need to then associate data from other FCS files with it. So you need to apply a compensation matrix. You may need to calculate MESF values from beads. So there's a lot of things that you might need to bring in outside of the FCS file into the FCS file as well. But then once you get up above these 15 to 20 colors, it seems like we're all in consensus that it becomes difficult somewhere above that, and that is because of the number of different off ramps that you can take, right? That if you have 10 colors, maybe there's 15 plots that you need to look at to compare one marker to another, and you can go down to cell lineage and then look at some sort of like activation marker or cytokine to see like what's going on in those cell types. But once you've got 20 to or above markers, then it becomes very difficult. And Sean, you brought up an interesting point that the visualization of that data and understanding of it is the difficult part. Can you expand about on that in terms of why that you think is the primary barrier here?
Yeah, I mean, I don't think necessarily it's the primary barrier, but it's one where I think a lot of people struggle to start with, right? Because we're a lot of folks who are doing this kind of flow, they didn't just start, jumping in off the deep end, doing 15, 20 colors plus. They started somewhere else where they're used to looking at histograms or used to looking at 2D plots side by side. And I think you mentioned earlier that there was kind of an emotional component to looking at stocks, and I feel like there's an emotional component to looking at bivariate plots, right? So part of that challenge is besides the logistics and the technical details of how do I create a UMAP, how do I create a TISNI, how do I use SOM, and use all these kind of algorithms that are coming out. It's like, how do I change my mindset of trusting these new kind of visualizations that I've never used in the past. But again, I mean, that's kind of a small part of it as well, because you need to get insights out of this data, and you need to report the information that you need somewhere else in some sort of standardized format, right? I mean, if we take those results and we just put them all out to Excel, that's fine. But if we're not organizing and we're not standardizing, we're not putting that into some sort of database or table that can be mined for that information across many different samples, across many different cytometers, across many different modalities, then we're losing a big part of the information. I think that's going to be one of the challenges, is getting this information standardized in some sort of way that we can work between different samples, work between different research institutes, work between different cytometers, and I see some of that in the paper. They're trying to think ahead, and this OMIP is set up for the BD instrument, but it can also be used on the ID 7000, right?
Mhm.
And it can also potentially be applicable to other cytometers. But I think I'm really excited actually about what Ryan's kind of been working on with his SoulCap project, in an effort to kind of standardize information and annotations going into these data sets before you're even getting results out, because that's going to be immensely helpful for working with these high dimensional data sets down the line.
Yeah, I think that's really interesting. I'm glad you brought up SoulCap. So Brian has mentioned that to me before, and I know Ryan, you're working on that. Read a little bit into it, but could you explain what you're doing there?
Oh, thanks for that. Really appreciate the shout out, guys. So the challenge that we face that led me down this road, and I think it's a challenge that's faced by everybody in the field, is the terms and the words we use matter, right, in discourse, and even perhaps more so in scientific literature. And if you look at, if you throw an X-ray up and have a doctor look at it, everyone can agree that this is a tibia, this is a fibia, because some guy 3,000 years ago drew a map and named these things. We don't have that in flow cytometry, right? We use these words like T cells, B cells, and K cells, but when you get down to the nitty gritty of what that actually is, and you had to point to it in a plot, people would point to different things or use different words to describe these same things, and the words we use are kind of vague, like bright or dim or double positive. We use different words and different words to mean the same things in different ways, and this is just a real challenge. When I come from a bioinformatics perspective, when you start doing big data analysis, we just can't integrate or bring data sets together because people don't do that. So the whole idea we have is, can we just agree on how to define what these things that we look at every day are, and maybe start using the same terminology and the same definitions? And if we do that, that's going to enable awesomeness, right? We can't do AI, ML, just to point to the buzzwords everybody's talking about nowadays. We can't do AI and ML unless data is consistently tagged, right? So we can't train on flow cytometry data across large studies because people are using different words to describe the same things or analyzing things in a different way. So the whole SOCAP initiative is setting out to standardize the terminology around cell populations, link that to ontology, so we can derive better knowledge, link that to reagent panels. So with this reagent panel, this is everyone can from BD or any other vendors. This is a T cell, and this is how we gate to that. I think that's just going to make the world a better place.
Yeah, it's really interesting you mentioned that because, there are the broad populations. Everyone knows their T cell, their B cell, your CD3 marker, your CD19, CD20 B cell, so on and so forth. But then there are so many subpopulations, right? And I think that's where all of a sudden you start going off the rails. And especially, too, when you start going away from the T cells, B cells, you start going myeloid, macrophages, monocytes, all of a sudden there's even more. This is what I did my thesis on. It just felt like the Wild West comparatively. I was kind of jealous of the T cell biologists because at the time it felt like they had so many more populations defined. You could really dive down into it. But then, to your point, it's still emerging and there's still discourse on those subpopulations. And so trying to standardize it just really helps everybody speak the same language and interpret the data in a similar, or have the ability to interpret the data in a similar way.
Mm-hmm. And we don't want to force anybody to gate a certain way, but if you've gated this way, this is what we want you to call it.
Mm-hmm.
Yeah, I think that's super important, and because one thing we see from folks using FCS Express is, just for instance, somebody calls something CD19 plus and they spell out plus PLUS, and another person puts a plus symbol, right? Even that, if you're taking that data and you're putting it into a database to try and mine information from that later through AI, like that's two separate things that we have to try and figure out how to reconcile, just with one kind of nomenclature. And if you're doing that across 50 plus markers and you're doing that across 2 instruments and then 3 research sites, everything just falls apart, right? It's going to be really hard to kind of organize that in some sort of way that we can set up for using AI in the future, and the powers that are going to kind of come with that. It's
if I could, just like to add on to that, there's so many ways that flow cytometry data is getting more complex. It's not just that we have to do a 50 color experiment. We're not going to do a 50 color experiment and run one sample through that, right? We're increasing the number of studies that the number of samples we push through a study. If we're just hammering one nail, it's easy. We have to hammer 3,000 nails as a challenge, and that goes for everything in flow cytometry. Running one sample, easy. Run 3,000, we just have to manage a whole lot more. It's just that gets complex, and the biology gets more complex. And I think that's one thing that we see as well is start running these large studies through. It's the complexity in the biology that just adds a big. That's when that's when things can blow up, right? You set up your whole methods, and then you get that one sample that looks different than everything else, and then you spend all your time trying to figure out how to what's going on in this one sample because you see heterogeneity that you just didn't see before. Everything when everything scales, everything gets more complex.
That's it. So, Ryan, to me, this sounds a lot like the Human Genome Project, right? Where basically a framework was developed, like a reference map, to say this is where everything belongs. Anything that we say or contribute needs to be mapped back against what should be or what we all accept as like the overall blueprint of what a human genome looks like. Mm-hmm. Is that a fair comparison there?
Yeah, the human immunome is something that's been talked about for a long time.
Okay. I think, too, what it does is it simplifies things and it saves work, right? One of the stories that I always like to think about from history was about the Spanish Armada going up against, the British Empire. There was this one naval battle they had, and the Armada totally overwhelms the Great Britain as far as numbers are concerned. but they don't end up winning. And one of the stories that came out of it was that the cannonball size for the British Navy was standardized. And so it was just easy to grab a cannonball and fire, whereas that wasn't the case for the Spanish Armada. They had all different size cannons, all different size cannonballs, and so they're just less efficient, effectively getting those cannonballs out. And so here, the way I bring that up is this saves work. It makes it more efficient. The data is then interpretable across different studies when you know you're talking about the same thing.
Awesome story. So true.
That's it. And, to go back to our news stories, like if we think about AI companies then trying to come back and repurpose drugs, if they can grab from this standardized data set, again, they can understand what the impacts might be as they try to translate from cancer into autoimmune or from one indication to another.
And I think it's not just flow cytometry. I mean, obviously we're very invested in this, but we're not the only technology out there looking at single cells of the immune system, right? And if we can standardize across, just think of what we can do if we start integrating data between our technologies and other technologies, bridging that gap and trying to use it. I guess this the different cannons. That might be the analogy we can go to, right? We have all these cannons we can shoot at this data we're trying to understand, and if we're not standardizing terminology across technologies, we don't have a hope in heck of understanding what we're looking at.
That's it. So if we're doing single cell sequencing, so if we're doing proteomics or even single cell proteomics, how can we relate that back to flow results or other things that we're getting?
Exactly.
Oh.
We have to be using the same words, the same definitions, and we're not, even within our own field. And sure, we're not talking to the people across the street as much as we should.
Yeah. All right. We are getting relatively close on time, so I'm going to push. I'd like to talk maybe 2 more minutes on just automated analysis. So, we talked about bivariate plots and manual gating a little bit. What do you think is the next steps in terms of getting some of the UMAPs and clustering algorithms and things like that into drug development processes and robust enough to be used for decisions on should this drug be allowed or not? Or what do you think the next sort of complex technique is that will be allowed into that type of decision making?
I think trust is a big one, and that's both getting the tools to the place they can be trusted, and getting people to trust them, because that also requires education, and so both of those things have to happen, and that's a complex. It's a lot of complexity behind there. Some of we've seen that a long time for a lot of these automated methods. You change your parameters, you're going to get a different answer if you run it again. Really simple things like that. And it's like, why am I getting a different answer? Well, your seed is different. There's so many things. As you go to more complex tools, more things can go wrong, or things are different and things don't get understanding. And so on the bioinformatics side, we have to make sure that these tools are robust, they're reproducible, we get the same answer. And on the biologist side, we have to understand how they work. It's not just, I don't think it's going to ever be, pushing a button is a holy grail. But if you don't understand what that button does and everything that goes beyond that, when the wires aren't connected properly, and all you can do is push a button, you have to call in the experts, and that gets hard. You don't have to be calling a plumber every day because your carburetor's not working. You don't understand what's going on between the button and what's going inside the sink, right?
That's it.
I think one kind of interesting statement I saw in that paper was they said manual analysis is critical to assess data quality and separation and markers in any flow cytometry panel, but in many cases additional insights can be gleaned from high dimensional panels using exploratory computational tools, right? And I thought that was a really great statement because it shows to me that the authors of this paper understand that a lot of the high dimensional tools are currently exploratory computational tools, right? They understand that it's not a magic button right now, right? And I feel like a lot of people coming into flow cytometry, they see UMAPs at a poster, they see high dimensional visualizations in a paper, and they think that, okay, yeah, there is just some button that you push to generate these insights. I think a lot of this is like Ryan said, people have to be trained, and then people have to learn to trust these techniques, and they can only get there by learning, right? And learning about them is hard currently. So again, I think education here is going to be really important to build that trust, because there's a lot of things that we can do with these tools, especially as automations come through and gating. A lot of kind of Ryan's work has been about automating gating and taking the subjective component out of that. That's going to be really excellent, and that's going to help us kind of set up for more success with the high dimensional analysis.
Agreed. Looking forward to it. Yeah, I mean, we could have probably, I don't know, 4 to 20 hours more content, I think, on this one topic. But I do really value your time, so I'll speed through, I guess, some of the ending parts here. With all of our episodes, we do like to request feedback for next episodes. That way, we can have some questions to answer. So the fan feedback I'd like to request from all of our listeners is, what is the most and least impressive example of logistics or lab analysis that you've worked on for clinical trials? And the reason this question came up is we did get a site that shipped us a sample for a trial. That sample was 3 years old. So that now ranks up there with the least impressive of logistics in terms of clinical trial execution I have seen yet.
Now, that was a fresh sample, though, wasn't it?
That was a fresh sample. Just to be clear, that was not a PBMC. That is correct.
Yeah,
it was.
They found it. They said, this needs to go to KCAS. You better send it immediately. And there it went. So,
well, I have to imagine, what did their rocker look like where that sample had to have been on? I'm thinking they left it there, and it was just. Is there like a mountain of samples that were there, and it just got covered up? I don't know. I'm kind of speechless.
There's just some questions, right? A lot of questions that come up there. But looking forward to questions or feedback that we get from that. And to that point on a human element, for our guests, what's the longest trip you've ever taken in terms of transit time from your house to where you actually got to the destination?
Don't ever go through Heathrow. It's not where it is; it's the places you have to go to get there. And going through Heathrow. So I was trying to get to Crete for a beautiful place for a talk. And it was great, go through Toronto and going over there, and then you get to Heathrow, and it was a windy day. And it's not just me; it's 50,000 other people stuck because it was a bit windy. I think I spent a whole day basically in Heathrow, and that's on ended up being a two and a half day journey.
Wow.
Yeah, it's just not pleasant.
I'm assuming nothing in the airport can make up for the fact that you're there for 24 hours longer than you expected to be.
Nothing.
Well, there's one thing at Heathrow. In the duty free, they generally have giving out free trials of whiskey all day, all night.
First name basis.
So, yes,
that makes up for it right there. Well, maybe.
They see me coming a mile away.
I guess it depends on what whiskey they're giving you.
After a couple hours, it doesn't matter.
Yeah.
Yeah. As long as it's not the plastic bottle stuff. That after a couple of hours, that might lead to headaches. So.
Goodness. Sean, what about yourself? Longest trip there?
Yeah, I mean, I've had the opportunity to go back and forth to the Philippines from New Jersey a lot of times, and I say that's probably one of the biggest slogs I've always had. They now do direct flights, which is helpful, but it used to have to be 3 connections, or you stop and refuel in Alaska, and then you stop somewhere in Korea, and then you go to the Philippines. But I think the biggest challenge for me is I get off the plane after being on planes for almost 24 hours. And then generally where I go in the Philippines with my family is it's about an hour north of Manila. And that hour, I say an hour north, it would be an hour north in New Jersey. In Manila, it's possibly a 4-hour drive to get there. So that's been the most challenging thing for me, getting off a plane for 24 hours and then, having to spend 4 hours in the car for the last 25 miles is somewhat frustrating. But
the box just got smaller.
Yeah, it's always exciting though. I can't complain. It's always exciting going over there and seeing family that I have.
24 hours though. What did you have? At least a decent sized seat? Did you have some leg room?
Well, no, I'm going to say no because that's when I was traveling earlier, when I was younger. So I didn't, you know, didn't splurge for any of the kind of economy plus. So the only upside to making multiple stops is you can get off the plane and stretch, right?
That's
But
definitely good. So for me, I just traveled from our Philly location to our Kansas City location yesterday, and I'm 6'3", and so I'm sitting in the seat, and my knees are hitting the seat in front of me, even without the person leaning back. So I have had flights before where somebody didn't realize that my knees were a part of their seat, and there was no way that they could go back, and they kept on trying to go back. I'm like, could you please stop? Like, I want to be able to walk after this flight.
Goodness. I think mine was probably the CrowdStrike adventure. So I was in Alaska, like at the airport, and just trying to get back. So I think I had like worked like 18 hours after I was supposed to be on the flight, and they're like, okay, we can't get you on this flight, but we can totally send you to New Jersey, and then you can maybe get to Dallas from New Jersey, and then we can get you back to Philadelphia from Dallas. I'm like, that doesn't sound right to me. They're like, well, we can totally do it. And I spoke to another agent. They're like, do not get on that plane. You will never get out of any of those airports, and you'll be stuck wherever you are. So, probably, I think it was 72 hours later, I finally just rebooked on a direct flight, and that was that. But
So it's interesting that you mentioned CrowdStrike because this trip taking me from Philly to KC today actually was supposed to happen when the day of the CrowdStrike thing. And so my flight, I'm leaving for the airport and I get a notification that my flight's canceled. I'm like, wait, what? Why is it canceled? The weather's beautiful. And so I'm trying to figure out if I could reschedule. What could I do? 2 hours later, figuring out about the CrowdStrike and all that, just decided, all right, we're going to cancel this one. We'll reschedule some other time. And I was thankful it only took 2 hours of my day. I know we had a team member who then was supposed to go out to Kansas City that Sunday, so a couple of days later, and ended up spending 8 hours in the airport not to leave, and then finally was able to get out on Tuesday. Now, they didn't stay in the airport until Tuesday. They did go home, so glad about that. But yeah, it was crazy. Did you guys get impacted by that at all?
I don't think anybody on our team was traveling that day, and we were, there was some minor interruptions, but were lucky enough to not have a major impact, at Denovo software, and I think there was some really graceful recovery and a lot of our kind of IT procedures and kind of forethought around, what can happen in cases like this really came into play. It was actually really cool to see, FCS Express Denovo software has been part of Dotmatics for 2 years now, and Dotmatics it's a big company. We have a lot of different software tools and platforms, but it was amazing to see kind of some of the forethought from our IT team and some of our security directors. It really went into play, and we had very minimal downtime for, I know anybody at FCS Express, very minimal downtime and just overall. So it was cool to see everybody come together around that in a way, but it was not cool to have to pull everybody together to do that.
Sure. Yeah, on the software side, I guess the CrowdStrike was likely, more impactful or more sort of closer to home there. So makes sense on that front. With Tripwise, of course, the next thing up there I have is Aliens, and always like to have some sort of more far out there request. So for Aliens, Sean, what is your take? Alien existence, the likelihood of it, any amusing experiences to bring up?
Yeah, I think aliens can exist. It's I feel like there's something else out there. I remember having one experience camping. It's always something camping out in the deep woods when you have an alien experience,
Uh-huh.
right? But seeing some sort of light in the sky and being frightened and getting out of the campsite in the middle of the night when I was much younger. So I imagine it probably wasn't an alien coming to look for me when I was camping with my family, but I do think there's something out there. I think there has to be. The universe is so vast. So I don't know if I'm gonna meet them in my lifetime, but maybe I already have. I don't know.
There you go. Can't disprove it. All right, Adam, what about yourself?
Well, you do know that I have an alien tattoo. I've always liked aliens, like the whole culture thing. I think it's really cool. As far as whether or not I believe, I just think that there's too many possibilities out there. The universe is too vast to, just say outright that is not a possibility. So, certainly lean on that side. I will say I haven't been abducted, much to my dismay there. But what can you do?
I just want to follow up on that. You haven't been abducted and dismayed on that. There's a whole subgenre of aliens, right?
Right. Now it's out there in the universe. I don't know. Maybe I'm asking for something I don't actually want.
And so, Ryan, that's a good segue. What about yourself?
I mean, I'm a scientist, right? The universe is large. We just can't fathom it. The vastness of how big it is. Roll the dice on that one, and you're going to come up with 20s a few times, right? And just look at what's going on Earth, right? If you look at some of the stuff that we came up with, evolution, you're like, what the heck is that, right? I mean, and that's just on our little speck of this inconsequential backwater end of the spiral arm that we're on. They're out there.
Okay.
But it's going to take a long time to get to them.
Yeah. I like that all of the responses have been very statistics focused and then one platypus reference. So I'll take that.
What are you, Brian?
Absolutely. I would also go with the statistics route, like, with billions and billions of star systems, then, at least one of them has to be something. Likewise, I don't know how likely it is to ever meet one just due to the vast distances involved, but optimistic. It would be nice. Again, within the subgenre of aliens that I prefer to think about.
not the alien aliens.
Correct.
The friendly ones, yes. I'm not talking Predator here.
We want just the fluffy ones.
All right. Excellent. Well, thanks, guys. We'll end here. Looking forward to the next recording. Again, talking about now very low dimensional flow, right? So how do we make the most out of 6 colors? What have we gotten in the past from low color flow, and when is it a good idea to design that type of panel for a clinical trial? So thanks everybody for listening, and we'll look forward to talking to you on our next episode.
Yeah, and thank you both, Sean and Ryan. Really appreciated having you on. Great discussion, and thanks everyone for listening.
Thanks for having us.
Thanks for having us.